So we're here to talk through Prasanna's Repeated Neighbors Sudoku puzzle. This is a style that Deb Mahanti debuted in an Indian Sudoku Championship a few years back. And it's also a style that Prasanna chose to highlight in the recent Sudoku Grand Prix round that India put together. And this was a potential submission that, again, was judged a little challenging for the goals of the competition, but it's a pretty phenomenal puzzle and uses the Repeated Neighbors rule quite well. So it's one we thought we'd talk through and showcase exactly how that rule matters. And even before I place any digits here, I'm going to try to just mark repeated neighbor cells that are easy to get and useful to get. And the first thing to note about them is they'll always take for instance, this shaded 8 has repeated neighbors near it. It will use at least one of the digits to the left and right and one of the digits to the top and bottom as its repeated neighbor. It's actually possible it would have two sets of repeated neighbors, but it'll always at least have one that's left-right and one that's up-down. When you have a cell that's on an edge, one of its repeated neighbors must be the cell I've just circled. And since this sits in the same region as that circle, the linked cell is over here. I like this notation a lot because it's not so confusing with circled cells and diagonal links, but this says that the same digit will sit in both of these places. One of the things you may be tempted to do, we won't do this for all the circled groups we mark, is to now think about these cells collectively and which digits do they see. They see a 1, they see a 2, they see a 3, they see a 5 and a 6, and an 8 and a 9. So the two digits that are possible for them are 4, 7, and that means this is either 4, 4 or 7, 7. Right now we don't know which, but we'll quickly figure it out. The other thing I do is mark when I've satisfied identifying for a shaded cell the repeated neighbors for that cell. So these two cells I've now identified the repeated neighbors for. You'll notice that they always come with shaded cells diagonally adjacent to them, and this is a consequence of the if and only if nature of the shading, that all cells that could be shaded are shaded. So we'll see this pop up again down here. This 3 needs a repeated neighbor. It's one of the vertical numbers, but if it were the number in this circle, that circle's already in both of these regions, so it can't be either of these digits. It's impossible for the 3 to repeat with the 4 or the 7. So the 3 repeats with a digit below it. We talked about seeing diagonal shaded cells. Well, if these two cells, this one here and this one here, are the ones that are repeated neighbor, this cell right here would have to be shaded to satisfy the rules that all cells that have repeated neighbors are shaded, and it's not. So consequently, you can't use the cell here for the repeat. The repeat has to sit in this space, and we can mark those two cells. Let's look for the repeated neighbors of this gray cell. Well, 3 are in the same region, so the 4th, which is in the second region, has to be part of the repeated group. And now it's a question of the top or bottom. These two effectively eliminate a connection to also be in this cell. So we mark this, and again we see that comes with a set of diagonal neighbors that are both shaded. So those pairs all must contain the same digit, whichever digit gets filled in there. This puzzle, if you haven't recognized it yet, has diagonal symmetry, and as a consequence of that symmetry, the thinking we did down these two columns we could do across these rows, starting from the right. I'm just going to mark the end result, which are the same sets of circled pairs that we did before, and those satisfy these 6 gray cells, and this one is actually a group that has 2 repeated neighbors, but as I said, that's perfectly allowed in the rules. Now, in the bottom set of shaded cells, these 2, which are also circled cells, don't yet have a repeated neighbor identified. If the cell beneath this one was part of the repeated neighbor, then either of these would be the shaded cell as well, because if it were this group, it obviously can't be this group, but if we're this group, this would end up being shaded. What it means is when you're looking for the partner of this shaded cell, you're looking for something diagonally it's also shaded. That's only this cell, which means that it's only these 2 that are another pair. And so we'll go ahead and mark that in. And that fulfills those shaded cells. We still want to notate what's going on with the group in the upper right. There are a few places to start with that, but the easiest is probably either of these cells, which have, again, 3 in the same region and 1 outside, so the outside one has to be part of the repeated neighbor group here. And we're looking for diagonally adjacent shaded cells, so it can't be this one because this isn't shaded. It can be this one because these are shaded. So this is the link. Equivalently, this is the link, which accounts for these 3 cells. Let's come down to this cell. It has 3 in the same region, so it's diagonal neighbors to the left. Is it part of this group or is it part of that group? Well, this group already exists in this column, so that's the line you can draw. This is the line you can draw. So these 3 cells all contain the exact same digit, actually. So this is the first triple we find in this puzzle, but we've accounted for those cells pretty well. And it's the case with the last 2. We've not really marked the neighbors for the last 2 cells. This, again, we need to have a partner to work that's also shaded. The only partner is to the lower right. So in this puzzle, you can say that these cells are neighbors. In this case, I think just the normal Sudoku logic of the puzzle would get you that pair easier, but right now we've effectively marked all the pairs in the grid that must exist. And we can now just start to do some Sudoku solving, but with this interesting extra constraint. It's almost worth its own variation someday itself, but the linked cells work together slightly differently than you normally see in getting a solution. So for instance, one of the easiest numbers to place in the puzzle is a 9. We instantly now know that the digit to the lower left is the same digit and can place that 9. That gives us all the 9s like this. One of the consequences that comes from all of these linked cells is a digit like this 1 eliminates a whole lot of cells in the column to the left. For instance, it can't be a 1 in this cell, can't be a 1 in this cell. If we'd done regular logic, we'd get this one. So we've eliminated the 1 in this cell. The 1 in this cell is eliminated by coming up. The 1 in this cell is eliminated by coming up. There's only a single spot left for 1 in column 3, which is all the way at the bottom. So basically avoid the paired cells, which all see that digit. That gives us this kind of progress. Mark that one there. We have cells in this upper right group that only have a few choices left. For instance, this cell starts with being a 3, 4, 7, 8 based on just looking in this region. This sees a 3 here, and this part of the chain sees a 4 here, so all that's left is a 7 or an 8. So we'll mark that in. And something similar happens with this chain, that this cell sees a 3 and a 4. This cell sees 1, 2, 5, 6, 9, so all that's left actually for this chain is 7 and 8. And what will be the case is 3 of these will be 7, 7, 7, don't know which of the groups, and the other 3 will be 8, 8, 8, all diagonally linked. And so that doesn't leave a lot of room for other digits around there. Specifically things like this middle region, we've now sort of blocked off both of these from containing a 5. A 5 has to be in one of these 2 cells. One cell links down here and gets eliminated immediately, so the 5 is actually in the top. And that also puts a 5 here. This is the effect of the linking as digits come pretty quick. Gives this 5, gives this 5. Looking to the top, we get that 5. We get that 5. One of the next spots potentially is to look at this long row and figure out with some of the linked cells exactly what's possible. And also this column looks pretty full. I'm going to start with the column actually. It looks like this cell can't be a 6, so one of these 2 cells is a 6. But remember, we have some linked information. This 6 also eliminates this position at the top because the circled cells must be the same digit. And so what that means is we're left with a 2, 3 option here. The middle is also in a 2, 3, 6 state right now. This cell can't be a 6 because it's already in this region, so this has to be a 2 or 3. And the one above and to the right is also a 2 and 3. So now we've actually marked pairs for this row that cancel what's nearby. Critically, if this is a 2-3 and a 2-3 pair, the digit here can't be a 2 or a 3 because they're already present in that row. So this is where the 6 goes in the middle group. That quickly gives that digit right nearby. And that means there's a 2-3 pair coming up the center here. That eliminates all these cells for a 3. This eliminates the neighboring cell for a 3, so there's a 3 up here. And that means the 2-2 is here, and the 3 sits there. These two 2s give us a 2 over here. Put a 2 there. We have two 2s that give us a 2 at the top. It gives us a 2 over here. Coming across, 2 in that cell, 2 in that cell. We finished all the 2s. Now we have, let's see, this digit will be a 4-7 to finish out that column. We have this set here. What's left in this group is a 3-4. I'll mark it in. It's not going to be immediately quick to fill. What's left in this group is a 4-8 for this row. But this cell and this cell have to both share a number, and what we see is a 4 eliminates from here. So this is the 4. This is an 8-8. This 8 finally forces this chain of triples to have 7-7-7 and 8-8-8 as I'm writing them in. That eventually gives this 8. We have an 8 in these cells. We'll now come back and look at the 7s. The 7's over here. This is a 4. Means this is a 7. This is a 7. This is a 7. That is a 7. The 3s eliminate over here. We get something like this. This is a 6. This is a 3. That makes this a 3. Got 8. 8, 4. Filling just out this box, the top row only has a 1 left. This needs a 4 or 6. This needs, it looks like, 4 or 6, but there's already 4 in that row. This is a 3, 6. What's left here is another 4, 6. There's a 1 in one of these options, and you're like, well, this puzzle has too many solutions. And this is where we get to needing to use the converse rule, and it's sort of sneaky to include it, but whenever you have a if and only if kind of construction, take for instance the 3 up here, if a 3 is diagonally down to the left of this 3, we now would have a new pair of repeated neighbors, and so in this group the 6 has to avoid, sorry, the 3 has to avoid itself, so it splices like this. We get to here. And you'll say, why did I choose these entry rows? I should have chosen a column like column 1 because there's another avoidance, which is this 6 has to avoid itself again. So you get 6, 4, 4, 6. And we finished the challenging puzzle. It actually takes a fair bit of work to get going, at least to talk through it, but what's really critical is looking for diagonally adjacent shaded cells to tell you where the partnered things that are circled must sit. And once you mark all of those, then it's really just an exercise of tracking the numbers that can collectively go into 2 shared spaces or 3 shared spaces. And we hope that the next time you see a repeated neighbors Sudoku, you'll be much faster to get to a solution. Thanks for your time.